In this video, our focus is to convert an improper algebraic fraction into a proper algebraic fraction and then convert it into its partial fractions. The question is, what's an improper algebraic fraction? What's a proper algebraic fraction? So now a proper algebraic fraction is one in which the highest power of numerator is lesser than highest power of denominator. HP stands for highest power. N denotes the numerator and D denotes the denominator. So the highest power of numerator is lesser than highest power of denominator. That means an improper fraction could be of two types. An improper fraction can either consist of a fraction in which highest power of numerator is equal to highest power of denominator, or highest power of numerator is greater than highest power of denominator. Our focus is this first scenario in which the powers are equal. Let's get started with the first question. The question is, split this fraction into its partial fractions. Now the fraction is, the numerator is quadratic, x squared plus 3x minus 13 divided by a product of two linear factors, one of which is x plus 2, the other one is x minus 1. Highest power of numerator is 2. It's a quadratic expression. Highest power of the denominator after multiplication is also 2. Therefore, first of all, you will write that this is an improper algebraic fraction. Now, let's go into basic arithmetic. If I want to divide 7 divided by 2, 2 3s are 6 and the remainder is 1. This is called a quotient. 1 is the remainder and the divisor or the divisor, that is 2. That means quotient plus remainder over divisor, that's the way we should write this fraction. Or we can also write quotient remainder divisor. So if I write quotient remainder divisor, that is 2 1/3. 3 multiplied by 2 is 6. 6 plus 1 is 7, which is 7 over 3. So now, can I write 2 1/3 as 2 plus 1/3? Of course I can. So now this is the logic with which we will start working for this particular question. So x squared plus 3x minus 13 divided by x plus 2, x minus 1. The first step number 1, is multiply out the denominator. Actually, what does the denominator consist of? It consists of two linear factors. So multiply out the factors as much as possible because we have to carry out algebraic division. So x plus 2, x minus 1 after multiplication becomes x squared minus x plus 2x minus 2, which is x squared plus x minus 2. This is the divisor. We have step number 2 now. That is algebraic division, also popularly known as long division. X squared plus 3x minus 13 is being divided by x squared plus x minus 2. We have already seen this thing in the chapter of polynomials. I take the highest power from the numerator, take the highest power from the denominator and divide. So x squared over x squared is 1. Take this 1 and multiply with every term of the divisor and simply write it down. That is x squared plus x minus 2. Now you want to subtract it. So the best way of subtraction is change the sign and add. So this becomes negative, this becomes negative, this becomes positive. The x squared terms cancel off. 3x minus x is 2x, minus 13 plus 2 is negative 11. So now what do we need to do? We should separate out the things. The quotient is 1. The divisor is x squared plus x minus 2, which was obtained from x plus 2, x minus 1. So we have the factorized form. And we also have the remainder, which is 2x minus 11. And we write this thing as quotient plus remainder over divisor. So let me write this thing as 1 plus 2x minus 11 over x plus 2, x minus 1. Now this fraction over here, this needs to be broken down into its partial fraction. It's now a proper fraction. Don't forget this constant over here. The quotient remains on the side. It will be added up later. Now, before we proceed, let's decide on the case. It's a proper fraction. It consists of two linear factors in the denominator. So therefore, this is case number 1. And now I'll write this thing as 2x minus 11 over x plus 2, x minus 1 is broken up into a constant over the first factor, another constant over the other factor. Take LCM, that is x plus 2, x minus 1 goes down. A is multiplied with x minus 1 and b is multiplied with x plus 2. Equate the numerators. So therefore, 2x minus 11 is identical to a times x minus 1, b times x plus 2. You can find the unknown constants in any order. Let me get started by taking x is equals to 1. So therefore, 2 minus 11 is negative 9. A is multiplied with 0. B is multiplied with 1 plus 2, which is 3. Therefore, b comes out to be negative 3. That's the first constant that has been found. Now choose any other value which will eliminate the other constant. What if I choose, let x is equals to negative 2. Negative 4, negative 11, that is negative 15, is equal to a multiplied with negative 2, negative 1. Therefore, a comes out to be 5. So now a is 5, b is negative 3. Don't forget this one. Your final answer is 1 plus a is 5 over x plus 2, minus sign in the middle, 3 over x minus 1. That is the answer for this particular question. So our objective was to break this up into its partial fraction. What was step number 1? Step number 1 was multiply out the factors in the denominator, which we successfully did. What was step number 2? Algebraic division and achieve a quotient, a remainder, a divisor this way. In our worked example, the quotient is 1. The remainder is 2x minus 11. The divisor in the factorized form is x plus 2, x minus 1. That brings us to step number 3, which is about partial fraction. Decide on the case. Since it has two linear factors in the denominator, this is case number 1. How do we proceed? We write it like this: 2x minus 11 over the two linear factors. That is made up of a constant over the first factor, another constant over the other factor. Apply the concept of identity and solve for unknown constant. Last but not the least, do not forget to write the final answer as partial fractions.